in the region. The college comprises 5 schools: agricultural, earth and environmental sciences, engineering, chemistry and physics, life sciences and mathematics, statistics and computer science. Engineering is offered. The University of KwaZulu-Natal's College of Agriculture, Engineering and Science is committed to making a difference in our world, from the classroom and laboratory to the field. It provides one of the finest study and research environments on the African continent and is recognized internationally as a center of excellence. Agriculture, Engineering and Science is one of 4 colleges that make up the University of KwaZulu-Natal and is home to over 8,700 students and approximately 700 staff. 3 of the university's 5 campuses form the core of agriculture, engineering and science activities in the region. The college comprises 5 schools: agricultural, earth and environmental sciences, engineering, chemistry and physics, life sciences and mathematics, statistics and computer science. Engineering is offered on the Howard College campus, agriculture on the Pietermaritzburg, and all the other sciences on both the Pietermaritzburg and Westville campuses. Exceptions are agricultural engineering, which is offered in Pietermaritzburg, and geology, which is offered at Westville only. To compete with the best and to meet the challenges of the 21st century, South Africa needs highly skilled professionals in the areas of agriculture, engineering and science. We offer a wide array of interesting and innovative degree programs that open doors to a variety of different careers. Some degrees are unique to UKZN and are not offered at other tertiary institutions. For example, we are the only university in South Africa to offer a fully accredited agricultural engineering degree and one of only 2 universities in the country to offer a BSc in land surveying. Our postgraduate food security training program is the only one in the world, and we have the widest range of agricultural disciplines at any single South African or African campus. The choices of degree and the options on offer may seem confusing at first. Engineering degrees are more specific, and the options are usually career-focused. Emphasis is placed on training in the specific principles which engineers deal with in their professions. Engineering offers 7 different professional specializations. There are also degrees in land surveying or geomatics and property development. In science, there are structured or career-focused degrees. These include fields as varied as chemical technology, marine biology, industrial and applied biotechnology, and computer science and information technology, to mention a few. There are also more general degrees with a lot of flexibility. In this case, students have the choice of studying a BSc M stream in maths, physics, computer science, and statistics. All of these have a strong mathematical component. The other option is a BSc LES stream with a focus on the life and environmental sciences with subjects such as geography, genetics, botany, hydrology, zoology, ecology, and microbiology. In agriculture, there are various different options that involve practical and scientific applications. Students can combine science subjects with specific agricultural disciplines for a 4-year Bachelor of Science in Agriculture degree. These are more career-orientated. Agriculture and agricultural management are 3-year degrees with a higher practical component. Dietetics is a professional qualification that deals with the role nutrition plays in the promotion of health and the treatment of disease. Most degree programs across the college have field trips and projects that contribute significantly to the curriculum. This ensures that students learn in real-life situations under full field conditions. Many of our lecturers have received Excellence in Teaching awards, are recognized internationally, and are rich in practical experience. Students have access to excellent facilities that rank amongst the best in the world. 300 million rands has recently been invested in new teaching and research facilities, state-of-the-art laboratories, and improved equipment. The 30 million rands new School of Engineering building is the envy of engineering campuses across the country. Agricultural students have access to a 356-hectare research and training farm situated near the Pietermaritzburg campus. This facility provides students with hands-on training and is used extensively as an outdoor laboratory for teaching and research in areas such as animal and poultry science, horticultural science, and agricultural engineering. Adjoining Ukulinga is the Bisley Valley Nature Reserve, which supports a diversity of plant and bird species, as well as some large mammals. It provides a rich learning and research environment for staff and students. Based on the Westville campus, the college possesses unique facilities for research into higher voltage power transmission. These facilities are available in only 3 other places in the world and form part of the ESCOM-sponsored Science and Technology Innovation Park. The Science and Technology Education Center showcases the college's scientific achievements and promotes the public understanding of science, engineering, and technology within the region. The college houses a wide range of sophisticated equipment in its microscopy and microanalysis units, staffed by highly qualified and skilled technical specialists. The College of Agriculture, Engineering, and Science prides itself on its graduates who are highly sought after. In a market characterized by a shortage of qualified professionals in science and technology, our graduates are readily employed around the world in the fields of agriculture, science, commerce, industry, engineering, and research, to name just a few. Research plays a major role within the college and operates at the cutting edge of technology. The college has the highest research output in the university and produces the most research publications. There are over 60 well-established research groups and centers within the college. The African Center for Crop Improvement caters for students from all over Africa. It is one of only 2 African plant breeding programs on the continent. Based in the School of Agricultural, Earth and Environmental Sciences, the African Center for Food Security focuses on alleviating hunger in Africa. It offers food security training programs, undertakes academic and applied research, and provides policy and program support. Promoting sustainable engineering practice is the Center for Research in Environmental, Coastal and Hydrological Engineering, or CRESH. It deals with the interaction between engineering and the natural environment. The Mechatronics and Robotics Research Group in the School of Engineering provides an excellent research and education environment for its senior undergraduate and postgraduate students. Judged one of the best research centers at the university, the Center for Plant Growth and Development focuses on high-quality
Okay, good evening, everyone. My name is Mr. Ashwin Manival, and I'm one of the Principal Academic Development Officers in UKZN. I'm based at Pietermaritzburg campus in the School of Agriculture and School of Chemistry and Physics. And today you're joining a physics session. So from the start, make a few things clear. Okay, first let me introduce the persons that I'm going to be working with. Ursula Pillay is going to be our teacher today. She's going to be the primary lecturer. She's going to be delivering content and going over a few past papers. Ms. Randila Mshlongo is also a teacher in the sessions today. He will also be assisting you with some questions. If you have any questions, you can post it in the chat, and Ms. Randila will bring it to the main screen. And you can post questions as you're moving forward. Today's session primarily is based on grade 12 work. So I know that there's some grade 11 learners here, but we're working on the principle that some of your matric work is actually grade 11 work, because in grade 11 you do the matric work, and the second half of matric normally is mostly revision. So if there are some concepts in grade 11 that's not covered here, or if you need help with, I will post a link to our email box, so you can the grade 11s and the grade 12s as well, but more towards the grade 11s, can post on the email, and the tutor will get back to you. Goes for the grade 12s as well. If you have questions that you have that are not answered here today, you can email the email box, and the tutor will get back to you. So session is geared towards matric students. Thank you for attending. We'll be 2 hours. We may be a little bit over time. And can I please ask that you bear with us? There might be some load shedding in certain places. There might be connectivity issues. Teachers may go off and on, but just bear with us, even if those things do happen. This is the nature of online learning, right? So I'm going to hand over to Ursula from here, and she will start the session. Thank you for your attendance.
Okay, good evening, everyone. Thanks again for joining us on our first physics revision lesson. Today, we're going to work through past year exam papers. We're going to start today with working through the November 2020 paper. If you have a copy of the paper with you, then that's even better, so you can follow. I'm going to go through all the solutions step by step, show you how to answer these questions. Okay, so let's do this. Okay, so multiple choice questions. Some of them are checking or testing your theory, and other questions are calculation based. And then they've given us all the options. So for us to be able to answer that, we need to know what is, write it as delta T divided by delta T. And so of momentum, that is equal to the net force. Sometimes if you do, you know, or you can look at your equation sheet for help. So if we write it like that, then 1.1, the rate of change of momentum of an object is equal to the net force acting on the object. So the correct answer is B. The gravitational acceleration on the surface of planet Y with mass 2m and radius half r is, and then they've given us all these options. Okay, so the way you answer this question, we're going to write out the equation now for gravitational acceleration.
Ma'am, you're breaking. We cannot hear you.
Sorry. With mass m and okay.
Yeah, Ursula, your connection is not strong. Do you want to maybe log out and log back in? And maybe reset it. Do you think that would help?
Change my network here because I'm breaking up.
Okay, that may help.
Okay, can you hear me now?
Yeah, it's much more clearer now.
Okay, let me.
Much better now.
Thank you. Okay, so we were looking at, let's just go back to the question. So we were at question 1.2. Okay, yes, I'm starting again with 1.2. Okay, I'm going to start with question 1.1. Okay, so 1.1 is the rate of change of momentum of an object is equal to, and so I'm saying that when you get an equation like this or a question like this, sometimes the question is testing your theory and sometimes they are asking you to do calculations. So the rate of change of momentum, so the change in momentum is delta P. The rate of change of momentum means divided by delta T. So delta P over delta T is the rate of change of momentum. And if you write it out like that, then you know that this is equal to the net force. Okay, and if we look at all the options that we have, then the correct answer is B. Okay, looking at question 1.2, the gravitational acceleration on the surface of planet X with mass m and radius r is g. And then they want to know what is the gravitational acceleration on the surface of planet Y if its mass is 2m and the radius is a half r. Okay, so we've got one planet with mass m and radius r, gravitational acceleration is g. And how do we find the gravitational acceleration if the mass is 2m and the radius is a half r? Okay, and that's where we were. So g is equal to, from the equation for gravitational acceleration, g mass over r squared. For the second planet, if we had to write out the equation, we have g, the mass is 2m, and the radius is a half r, and then you square the whole thing. Okay, so if we rewrite this, I'll bring the 2 to the front. So I'll have 2 GM divided by a half R all squared is a quarter R squared. And I write it like that because when you look at this, that within, oh, sorry. GM over R squared is exactly the same. So that is just G. So what you have here is 2 divided by a quarter G. And 2 divided by a quarter is just 8G. So that is the answer. So if I go back now to my question, the acceleration on the surface of planet Y is 8G. So the correct answer is D. Okay, so that is how, what I want to show you is when you give you a question like this, the way to solve it is to first write this bit here that's given to you. And then when you write out the second equation, you try to write it out in the same form so you can compare. Okay. Question 1.3. The graph below shows how one of the physical quantities associated with an object in free fall changes with time. The label on the y-axis is omitted. Ignore air friction. Okay, so here's your graph. And then we can see on this y-axis we have time. Sorry, on the x-axis we have time. And then on the y-axis we have a quantity that remains constant throughout time. And they want to know what could that quantity be. So which one of the following physical quantities can be the label on the y-axis? Now, can it be the velocity? No, it can't. An object in free fall, the velocity is changing. Can it be the position? No, it can't, because the position is also changing. Can it be the weight? Well, the weight is mass. Very good. The weight is mass times g. The mass is constant and g is the acceleration due to gravity. That is also constant. So that is the correct answer. Weight doesn't change over time. Okay. Okay, so here's a question on momentum. A ball of mass m falling vertically downwards hits the floor at a speed v and bounces vertically upwards at a speed of 0.75 v. Which one of the following combinations regarding the change in momentum of the ball during the collision is correct? So we want to know about the change in momentum. So you want to know, they're showing us here the magnitude as well as the direction. So what we have to do is we must read the question, find the solution, and then match our answer. Okay, so that's what we're going to do now. So vertically downward speed of v. Okay, so we have momentum is equal to mvf minus mvi. Okay, so if when the ball is falling, they said the speed is v, and when it bounces up, it is 0.75 v. Okay, so if we put it in here, so we've got m into vf minus vi. So which is the final velocity? The final is the 0.75. So you have to choose which direction is going to be positive and which direction is going to be negative. Okay, so let's choose upwards to be positive. Okay, if I'm choosing upwards to be positive, pardon? Okay, it doesn't matter. It doesn't matter if you choose upwards or downwards. We'll just choose one direction and then we'll solve it that way, okay? So let's choose upwards to be positive. So V final is upwards, so it's 0.75 V minus, and what's the initial? The initial is V, but it's down, so it will be negative because I said upwards is positive. And so that is just V. So then you will have M into 0.75 V plus V. And that gives you 1.75 V. Okay. Now, in the front here, we have a plus sign. So what does that mean? It means that the direction is upwards. Okay, so it is 1.75 V upwards. So now that I've got that, I can go back to my question and look for 1.75, and it's upward. So that is the correct one. So that is my answer. Okay. In the next question, the base SI unit of the physical quantity work is, and they give us many options. Okay, so to be able to answer this, you have to find an equation for work and then substitute the units. Okay, so we will do, I can write on here, work is equal to the change in kinetic energy. And what is kinetic energy? It's a half mv squared. So what are the units for m? M is a mass, so the units are, it's kilogram, and v is the speed, so it's meters per second squared. So writing it out, you'll get m squared over s squared. And if we look here at the question, you can see the way that it's written. We can write it out the same way as kg m squared s to the minus 2. So that's the answer that I got here. I calculated it. I go look at the options they give me and which is the right one, m squared s to the minus 2, and that matches with C. Okay. If we move on to the next question, 1.6, the siren of a police car moving in front of a truck emits sound waves of frequency f. Both vehicles are traveling at the same constant velocity. The frequency of the sound heard by the driver of the truck is, okay, so we know that this is about the Doppler effect. If two vehicles are moving with the speed relative to each other, then you're going to hear a different frequency. In this example, they said both vehicles are traveling at the same constant velocity. Okay, so there is no difference between the relative speeds. So the frequency that the driver of the truck will hear is the frequency of the police car. So the correct answer here is just F, because the same constant velocity. Okay. Okay, moving on to question 7. We've got two identical metal spheres, P and R. They are standing on insulated stands and they have different charges. The spheres are brought into contact and then separated again. If the charge on sphere R after separation is Q,
The charge on sphere P after separation is, okay, so we have these two, they have two spheres, they have different charges. You bring them into contact, then you separate them. Okay, so what happens when they come into contact with each other? Okay, we know that because they have different charges, when they come into contact with each other, the excess electrons will flow between them until they both have the same charge. So after separation, if the charge is Q on R, then what will the charge be on P? It will have to be the same charge. So the correct answer will be Q. In this case, it's A. Okay. An AC generator, so the alternating current generator, it generates a current with a frequency of 50 hertz. So what does 50 hertz mean? It means 50 cycles in 1 second. Okay, so 50 cycles per second. That's what 50 hertz is. The number of times that the maximum or peak current is produced in 1 second is. Okay, so they want to know how many times do you get the peak current if the frequency is 50 hertz. So that means 50 cycles in 1 second. But if you were to draw out 1 cycle of AC, that's what it looks like. Okay, the current's alternating. It's positive for half the cycle and then it's negative. So this is a peak and this is also a peak. So here we have 1 cycle and it has 2 peaks. So if we have 50 cycles, then how many peaks will we have? It will be 2 times 50. So the correct answer is 100. Okay. Okay, question 1.9. In the circuit below, the battery has an internal resistance R and an EMF E. A variable resistor R is connected in the circuit, and the ammeter and the voltmeter register readings. Okay, so they register readings means there's current flowing in the circuit. Okay, the resistance of the variable resistor R is increased now. Which one of the following combinations is the correct representation of the change in the readings on the ammeter and voltmeter as the resistance of R is increased? Okay, so they want us to compare what happens with the ammeter reading and the voltmeter reading. So the way to do that is for us to look at our circuit, look at this resistor and now decide, okay, R increases. What happens if R increases? Okay, so here's our battery producing its EMF. So if this R increases, so this is now also testing our theory, right? So if R, let's see. If R increases, then it means that this voltage, this reading here is also going to increase. Okay. If the resistance increases, then in the circuit here, the resistance is going to increase, which means that what's going to happen to the current? If the resistance is increasing, the EMF is not changing. So if the resistance increases, it means that the current will decrease. So the ammeter is going to read a lower reading and the voltmeter is going to read a higher reading. So since we know that, let's look at the table and see the ammeter reading must decrease and voltmeter reading must increase. So, and that is the first option. Ammeter decrease, yes. Voltmeter decrease, no, no. that one. So the correct answer is A. Okay, so to be able to do these questions or to answer it, you must have gone through your notes and understand your theory. Okay, and the last question on the multiple choice questions. A sodium cathode, the sodium cathode of a photocell is irradiated with ultraviolet light as shown in the diagram below. The ammeter registers a current. Okay, so when ultraviolet light shines on here, then current flows in the circuit. Okay, and the question is, which one of the following will increase the ammeter reading? Okay, so this again is a theory question. So you need to know about this photoelectric effect and how can we increase the current here? How can we increase the ammeter reading? Well, we need to make sure that more photoelectrons are flowing in the circuit. And how can we do that? Well, we do that by increasing the intensity of the light. Okay, and remember, if we increase the frequency of the light, we wouldn't change this reading A, but then those electrons would have more kinetic energy. If we want to increase the current that flows through here, then we must increase the intensity of the light. Okay, so that brings us to the end of the multiple choice questions. I'm just going to carry on. If there were any questions posted, I will wait for you to, Mzwandile, to let me know. Okay. Okay, so let's go on to question 2. A 20 kg block resting on a rough horizontal surface is connected to blocks P and Q by a light, inextensible string. Okay, and they say that it's rough, moving over frictionless pulley.
Okay, I think we lost Ursula. Just allow for 1 minute, right? I'm sure she's going to get back on that. Thank you.
Okay, sorry about that. Can you hear me now?
Yes.
Yes, we can hear you, Ezra.
Okay, sorry about that. I
Can
keep
you
getting
loud and
kicked
clear?
off. Okay, thank you. Okay, so this is we're working with question 2. Okay, so when we're reading these questions, so remember they said a 20 kg block resting on a rough horizontal surface. That's their way of telling us there's friction. And they're telling us that it's a light, inextensible string. So we're going to ignore the mass of the string. And we know that at all parts on the string, the tension is the same. Okay. So then they tell us that a force of 35 newtons is now applied to this block at an angle of 40 degrees with the horizontal as shown. Okay. The 20 kg block experiences a frictional force of magnitude 5 newtons as it moves to the right, and it's even written all in capital letters so that you know that it's important, at a constant speed. Why are they telling you it's at a constant speed? Well, that means that there is zero acceleration. Okay, so now this block is moving to the right. And at a constant speed, and they told us that there is a frictional force acting there. Obviously, the frictional force acts in the direction opposite to the motion. So the block is moving to the right, so the frictional force will be to the left. Okay, so here's the first question. Define the term normal force. Okay, so that's the first thing. 2.1. What is the normal force? Okay, so the normal force is the force that the surface exerts on an object. So when an object rests on a surface, the surface will exert a force on that object, and the force will be perpendicular to the surface. So the normal force is a perpendicular force that the surface exerts. Oh dear. The surface exerts on it is a perpendicular force that the surface exerts on an object in contact with the surface. Okay, question 2.1. Draw a labeled free body diagram of the 20 kg block. Okay, so to draw the free body diagram, I'll draw it on here so we can see it. Oh, okay, let me show it to you here, and then I'm going to draw it on the other page because we'll need the drawing just now. So if we look at this, there's going to be the weight of the block which acts downwards. There's going to be the tension in that string. Then there is the normal force that the surface exerts. Then we also have this frictional force as well as the applied force. Okay, so those are all the forces that are acting on it. I'm going to draw it now on here. Okay, so
Sorry, Ashley.
yes.
Can all the participants please mute yourselves? Can you guys please mute yourselves, please? Because everyone who just joined, please mute yourselves, please. You can mute the video as well if you don't mind. Thank you. Thank you.
Okay, so to draw the free body diagram, so the dot represents object. Okay, so we have the weight acting downwards. We have the normal force perpendicular from the surface. We have the tension force. We have the frictional force. And here we have the, I'm calling it the applied force, FF. So those are the forces that act on the 20 kg mass. So that's called the free body diagram. Oh, sorry. Okay, now the question is calculate the combined mass M of the two blocks. So this is what we want to.
Gravitational force.
Pardon?
Is the weight the same as gravitational force?
Okay, the weight is equal to the mass times the gravitational force.
Okay, so when you're drawing the free body diagram, it is wrong when you say instead of weight, you write FG, which stands for gravitational force.
No, you can write mg. It is the forces. You can write weight or you can call it mg. Both are correct. But you can't just call it g.
Okay, sorry, ma'am.
Yes?
Isn't it much better to break down the applied force into its components?
Yes, you can do that. We'll need to do that when we are doing the calculations. For now, we can just draw it like that as the one force. If you wanted to, you could draw it like that with its y component and its x component. Yes, you can.
Okay, thank you.
Okay. Okay, so the question is calculate the combined mass M of the two blocks. So in here, they want us to find what is the mass of P and Q. Okay, so what we'll need to do here is if we're looking at this two blocks, we have the weight. Okay, so that's mg acting downwards. And then up here we have the tension. Okay, and remember this string has the same tension at all points. So for us to get to this mg or to find the mass, we first need to find the tension. And for us to find the tension, we have to go to this 20 kg block. So we're going to use the 20 kg block and we're going to calculate what is this tension here in the string. And then when we have that tension, we'll come back to this system here and calculate the mass. Okay, so that's what we're going to do now to find mass. Okay, so 2.3. So the equations I'm writing now are for the 20 kg block. And then we write that the net force must equal to mass times acceleration. Okay, and what is the net force? So if we are looking at the forces now, we want to find the tension. So we're looking in the x direction only. And then we use that to be plus x and that to be plus y. Okay, but actually we can change it. Let's just do x for now because we're doing this part, right? So that's going to be our plus x direction. So what are the forces, the net force acting here? So I've got the tension, which is positive because it's in the plus x direction. I have minus the frictional force minus F cos
You know, someone said we should like someone said that we should separate the weight into like its own components. Don't we like do that only when it's like on an inclined plane or something like that?
Ashila, you're muted.
sorry. Okay, so the mass times acceleration is 0 because the block is moving at a constant speed. Okay, so now we know what the frictional force is. We know what the applied force is. We can calculate what the tension is. So the tension is equal to frictional force plus F cos of 40 degrees. They told us that the frictional force was 5 newtons plus 35 cos of 40 degrees. And if you put that into your calculator, you should get 31.81 newtons. Okay, so using that free body diagram or using the 20 kg block, we were able to find the tension. Now that we have the tension, we're going to look at the system here now and solve for M.
Okay, Ashila, can I quickly come in? One of the students, when you're offline, one of the students asked a question concerning the applied force. So they want to know, when is it necessary that you split it up into its components when answering the question?
Oh, okay. So if you want to know when to use the components, it depends what you're doing. So for example, if we were trying to solve all the forces in the X direction here, then we would need this X component. So 35 cos of 40 degrees. If we were using the Y components, then we would need this Y component. Sorry. Then we would need the Y component here, F sine of 40 degrees. In this case, when they ask us to draw the free body diagram, you can just draw the force as it is. You do not have to draw the components. Okay, but you can draw the components. You only break them up into the components if you need them. Okay, I hope that answers that question. Okay, so now we're going to solve for M. Okay, so now we're going to look for the block with the mass M. Again, we're going to write, and now let's take downwards to be positive. Okay, the net force must equal to mass times acceleration. And what is the net force in the Y direction? So we have the tension that we have the weight acting downwards, and I'm taking down to be positive, so it's plus mg. Then I have the tension, which is pulling the block up. I've taken down to be positive, so that would be minus. Those are the only forces acting, and that must equal to mass times acceleration. Again, acceleration is 0 because of constant speed, so that's equal to 0. I'm trying to solve for M, but I'll just write it as mg is equal to T. Okay, I may be writing extra steps in here just so that you can follow. And M is equal to T divided by G. Okay, so if you're comfortable with the maths, you don't have to write out so many steps. That's equal to, and the value of T, we calculated it above. It's 31.81 newtons. Oh, okay, we don't need to write the units all along. Divided by G is 9.8. And put that into your calculator and you should get 3.25 kilograms. Okay, and that's what the mass of that block is. Okay. Oh, now at a certain stage of the motion, block Q breaks off and falls down. How will each of the following be affected when this happens? Okay, so 2.4.1, what happens to the tension in the string? Choose from increases, decreases, or remains the same. Okay, so we know that tension here is equal to mg. So if a part of this breaks off, so Q breaks off, it means that M is going to get smaller. So naturally, T will also get smaller. So it's going to decrease. Okay, 2.4.1. I'm just going to write it here for completeness. So 2.4.1, tension decreases. Okay, it's just for 1 mark. So you don't have to give any answers, but you know why that happens. Okay. Okay, now for 3 marks, they want to know if Q breaks off and falls down, how will the velocity of the 20 kg block be affected? So what's going to happen to the velocity of the 20 kg block? So here's our whole system. Let me just erase all of this. So if this mass here was to decrease and fall off, how is it going to affect the velocity? Remember, this was moving with some speed v, constant speed v, and it had some tension T. So when this Q breaks off and falls down,
We lost Ashley there for a few minutes.
Is she off, Nzondile?
Yeah, she's lost. So we can wait a bit for her to come back quickly. So if you guys, please.
okay, I'm here again.
Okay, awesome. Thank you.
Okay, guys, sorry about that. The weather's really bad here, so we're having connectivity issues. Okay, so we were here and we were trying to answer the question of if this Q falls and breaks off and falls down, what will happen to the velocity of the 20 kg block? So remember, the 20 kg block has a tension force pulling it to the right, and it has the applied force of 35 newtons pulling it to the left. And if the tension force gets smaller, then what's going to happen is this block is now going to accelerate to the left. It's going to move to the left. Okay, so let's just write out the answer there. So moving to the right, what will happen to the block? The velocity decreases. Okay. Because what actually happens is it accelerates to the left. Okay, or the net force is also going to be to the left. If you want to talk about it moving to the left, so you can choose whichever one. You must be guided by the number of marks for the question. Okay, so I think this was 3 marks, so you need to say a bit. Moving to the left, then the velocity increases. Okay. Okay, so that's the end of that question. Okay. Okay, so I'm just going to move on to question 3. A small ball is dropped from a height of 2 meters. Okay, let's use the highlighter. So it's dropped from a height of 2 meters and bounces a few times after landing on a cement floor. Ignore air friction. Okay, the position time graph below, not drawn to scale, represents the motion of the ball. Okay, so here we go. If we look at it, it comes down at 0.64 and then at 0.67 seconds, it's the first bounce up to its maximum 1.85 meters. It comes back down at 1.90, 1.97. It bounces the second time up to there and then it falls back down. Okay, so that's what's happening with the ball. And now let's answer the questions that they ask us. So define the term free fall. So what is free fall? Do you know? Okay, so motion in which the only force that acts on the object is gravity. Okay. Motion in which the only force acting on the object is gravity. Okay, so when only gravity is acting on an object, then that object is in free fall. Okay, now they ask us to use the graph. Okay, use the graph and determine. So lots of our information is going to come from the graph. The first thing is the time that the ball is in contact with the floor before the first bounce. Okay, so we must read the question and understand it carefully. So what is the time that the ball is in contact with the floor before the first bounce? So that is this time here, this time interval, because here's the first bounce. Okay, it's 0.67, that's the first bounce. Okay, so how are we going to find the time that the ball was in contact with the floor? It is just going to be 0.67 minus 0.64. Okay, so that's 3.2.1. Delta T is equal to 0.67 minus 0.64, and that is equal to 0.03 seconds. Okay. Okay. 3.2.2, the time it takes the ball to reach its maximum height after the first bounce. Okay, so the time that it takes the ball to reach its maximum height after the first bounce. So here's the first bounce and here's the maximum height. Okay, so how long does it take to reach there? How long does it take to get to that maximum height? So remember that the time it takes to go up is the same time that it takes to come back down. So if we want to find this time to get here, it will be 1.9 minus 0.67 and divided by 2. Okay, so let's do that. It's going to be 1.9 minus 0.67 divided by 2. That's just to reach the maximum. Okay, and you will get 0.62 seconds. So that's the time that it takes to reach the maximum height. Okay. So to go from here to there, up there, it took 0.62 seconds. Okay, the next question is, the speed at which the ball leaves the floor at the first bounce. Okay, the speed at which the ball leaves the floor at the first bounce. So here's the first bounce. What is the speed there? So that's what we want to know. What is the speed at 0.67? So in these situations or in the section, there are many equations that you can use. So I will show you with the one equation, the one that I think is the easiest. But there are different equations, and if you like to use a different equation, you can use your equation you're familiar with, as long as you get the same answer at the end. Okay, but where you have a choice, try to choose the one with the least work. Okay, so we're going to look at the section now of the first bounce. Remember, we already just calculated the time to reach the maximum. It was 0.62. We want to, and we know that at the top here, the final velocity will be 0, and they want us to find the initial velocity down there. Okay, so that's 3.2.3. So the equation I'm going to use is V final is equal to V initial plus A delta T. And I'm going to take upwards to be positive. Okay, so I'm trying to find VI, so I like to change the equation now. I like to write it as VI is equal to VF minus A delta T. And then that's equal to VF is the velocity or the speed right at the top, which is 0, minus acceleration is 9.8. But I've taken upwards to be positive, so then this is minus 9.8. And delta T, we've calculated above as 0.62. Okay, so if you put that into your calculator, you should get 6.08 meters per second. And that is the initial velocity at the first bounce. Okay. Okay, now the next part, and it's for 6 marks. So there's a lot of work to do, or a little bit more work to do. They want us to find time t indicated on the graph. Okay, so here is time t, and we want to know what is time t. Okay, so how are we going to do this? Well, we're going to have to use this third part of the graph now. So we were using the first bounce. Now we're going to look at the second bounce. We know that here the height, the delta y is 1.2. And we know at that point VF is 0. So looking at our equations, let's see what we can do. Let's try to find the initial velocity at this point, like we did for the first bounce. So if we find the velocity at this point here, the initial velocity, then we will find the delta t. Okay, so let's do that. Okay, so that's 3.2.4. Let's first find the initial velocity. Okay, so I'm going to take upwards to be positive. And the equation I'm going to use, because we know the delta y, I'm going to use that VF squared is equal to VI squared plus 2A delta y. Okay, so in this case, let's just put it in here. The VF is 0. It's equal to VI squared, which I'm trying to find, plus 2. Acceleration, again, it's going to be minus 9.8 because I'm choosing upwards to be positive. And delta Y from the graph is 1.2. Okay, so I'm just going to go quickly there to show you that this is the delta Y and we can read it off the graph. Okay. And so when we do this, you can just solve for, okay, you'll get VI squared, you'll get 23.52. And so VI will just be the square root of that, which is 4.85 meters per second. Okay, so that's the initial velocity for the second bounce. But we're still trying to get to t. That's what we want. The question is find t. So now we can find delta t. Okay. Okay, let me show you. No, let me tell you first. They want us to find t. Okay, and there are different ways that we can do this. So the way that I'm showing you is the first bit is where we're going to find the initial velocity at that point, because we know what the maximum height is. And then when I have this velocity, then I'm going to find the time that it takes to reach that point. So this time interval here. If I know that time interval, then I can just multiply it by 2. And then I can get this time for all of this. And then I can say 1.97 plus 2 times this, and I'll find t. Okay, and that's what I'm going to do. What you could also do is use this first equation instead of finding out, to find this initial velocity and saying that the maximum height, you can say that delta y is 0. So the ball went up there and back down. Okay, so there are many ways to do this. And I'm just telling you that the way that I'm showing you now is to choose to find that point there. And then I'm going to call this bit here delta t, the time taken to reach the maximum height. Okay, so now find delta t to reach the maximum 1.2 meters. Okay, so now you know which delta t I'm talking about. Okay, and the equation that we'll use is delta y is equal to VI delta t plus a half a delta t squared. Delta y is 1.2 meters. VI, we've just calculated it. It's 4.85. Delta t is what we're trying to find, plus a half. Again, it's minus 9.8 delta t squared. Okay, and when you see the equation looking like this, you know what it is. Okay, so if we write it out again, so half of minus 9.8 is minus 4.9. So I'm just going to rearrange this. It's going to be 4.9 delta t squared minus 4.85 delta t sorry, it was so quiet, I was just checking, plus 1.2 is equal to 0. Okay, I've written it out like that, so you can see that this is of the form ax squared plus bx plus c is equal to 0. Okay. And then when it comes to this stage, you know how to solve it now, but we'll just write it out anyway. So from here, delta t is equal to minus b plus or minus the square root of b squared minus 4ac, and all of this over 2a. Okay, once we have that equation. So that is equal to minus 4.8. And then we do plus or minus square root of minus 4.85 squared minus 4 to 4.9, 1.2 over 2 times 4.9. Okay, and then you do that, put that into your calculator, and you will get 0.5 seconds. Okay, so what is this 0.5 seconds? So 0.5 seconds is this time here. I'll put it in blue. It's the time to go from there to there. That's 0.5. But I'm trying to find t. So I'm going to say 1.97 plus 0.5 plus 0.5. Okay.
Okay.
So then
Okay.
t is equal to 1.97 plus 2 times 0.5.
You know what
That
it
is
is?
equal to 2.97 seconds. So this is what t is. Okay, so it was quite a bit of writing, but it was for 6 marks. Okay, so while there was a bit of maths to do, there was nothing too difficult. You just have to be a little bit careful with your signs, your plus and minus signs. Okay, so that is what the value of t is, and that's the end of question 3. Okay, do you want to see any questions? Okay. Okay, so go on to the next question. Okay, we're on to question 4. Okay, so question 4 is now momentum. Ball P.
Sorry, Ashley, there's a student who wants to ask a question.
Yes, okay.
Let's allow the student to ask a question.
Yes, what is the question?
Can go ahead, the person who's raising her hand. A person with their hand raised up, you can ask a question, please.
When we find t, why
Okay,
did you say 2 times 0.5?
Okay, good question. Okay, so when I was doing this calculation, so I said find delta t to reach the maximum. See over here, when I'm finding delta t, delta t was the time to reach the maximum height. So if we go back to the question, the time that it takes to reach the maximum height. So here's the maximum height. Oh, sorry, let me change my pen. So here's the maximum height, and the time taken to reach that is just here. It's this time here. So that's delta t. Okay, so when I use my equation here, when I did all of these calculations, I was finding delta t, which is the time to reach the maximum height. So when I found delta t, it's only going from this point up to there. But the question is, what is this final t here? That's what I want to find. So this final t is 1.97 plus the time to reach the maximum height, plus the time to come from the maximum height back down again. And the time to come from the maximum height back down is also delta t. So it's 2 times delta t.
Okay, thank you.
You're welcome. Are there any other questions? Okay. Okay, so question 4. Okay, we've got a ball P of mass 0.16.
I think we've lost Ashla again. We'll just wait a few seconds for it to get back on.
I'm struggling with the network as well here.
I think it's bad weather.
Yeah, we are in, I don't know, plus here we're in load shading anyways.
Okay, I'm back. Can you hear me?
Yes.
Okay, thank you. Yeah, the weather's really, really bad. Sorry about this, guys. Okay, so we were at this part now. After the collision, P moves west at a speed of 5 meters per second, as shown in the diagram below. Ignore the effects of friction and the rotational effects of balls. Okay. So first question is, define the term momentum in words. Okay, so that's a question you all like because you know the answer to that. So, oops.
Momentum is the product of mass and its velocity.
Very good. Excellent. So momentum. Okay, we can say momentum of an object.
There you go.
Is the product of its mass and velocity. Okay, and we like this section. Okay, they want to ask for 5 marks to calculate the velocity of ball Q after collision. Okay, so after collision, what is the velocity of ball Q? So we're just going to know that initial momentum is equal to final momentum, and then be careful with our signs, and then we're definitely going to get this one right. Okay, so if you are able to do it with me, that would be very good. So I'm going to go back here. And so we start by saying the initial momentum is equal to the final momentum. And I'm going to take that direction east to be positive. Okay, east is positive. I'm just going to write it as east so we don't think it's an electric field. Okay, so what is the initial momentum? It's the mass of P times V of P initial plus the mass of Q, V of Q initial, and that must equal to mass of P, V, P final plus mass of Q, V, Q final. Okay, and all these values are known except VQ final, which is what we're trying to solve for. Okay, so once you've got your equation and you know which direction you've chosen to be positive, we can go substitute the values. Okay, so let's do that. The mass of P is 0.16 kgs and V is 10 plus the mass of Q is 0.2 kilograms and V is minus 15. And that is equal to 0.16. And now V is negative because it's to the west, plus 0.2 times VQ final. Okay, so that's easy enough. So you can easily do this here. When you put all this in, you get VQF is equal to 1.6 minus 3 plus 0.8. I'm just writing this. You wouldn't even need this step. Many of you would be able to do it directly from there. And if you do that, and then you get minus 3 meters per second. So what does that mean? What does it mean when I get minus 3 meters per second? Okay.
Going to the wind.
Correct. It means that this direction is opposite to what I chose as positive. So then, so actually VQF is equal to 3 meters per second, and the direction is west. Okay. The question just asked for the magnitude. Okay. It just asked for the magnitude. It didn't ask you for the direction. But for completeness, let's just write it. So 3 meters per second west. Okay, so these questions are quite interesting or easy and enjoyable. Okay, and then for 3 marks, what is the magnitude of the impulse on ball P during the collision? Okay, what is the magnitude of the impulse? Sorry, so 4.2.2. What is the magnitude of the impulse? An impulse is just F net times delta T, and that is equal to the change in momentum. Okay, the impulse is equal to the change in momentum. And so that change in momentum, we're talking about P. Okay, it's just M V P final minus VP initial. That is equal to 0.16 into the final is minus 5 minus 10. Okay. And that is equal to minus 2.4 Newton seconds. Okay, so we can just leave that as 2.4 Newton seconds. Okay, because they asked us just for the magnitude. So the impulse is just 2.4 Newton seconds. Okay, so that's the last question for question 4. Okay, do you have any questions for me? Okay, no questions on momentum. Let's move on to question 5. Okay, so here's a drawing of a car, okay, roller coaster car. So a roller coaster car, let's get back to here, of mass 200 kgs with the engine switched off, travels along track ABC, okay, and has a rough surface. We know what that means, as shown in the diagram below. At point A, which is 10 meters above the ground, the speed is 4 meters per second. At point B, which is at a height h above the ground, the speed is 2 meters per second. During the motion from A to B, 3.4 times 10 to the 3 joules of energy is used to overcome friction. And then ignore rotational effects due to the wheels of the car. Okay, so all the information except for the frictional energy used to overcome friction is on the drawing. Okay, so the first question, define the term non-conservative force. Okay.
Ashila,
Define non, yes.
can I quickly ask you a question? There's some
Yes.
talk chat about a compass. I'm not sure if you mentioned the compass in your explanation somewhere. Somebody's asked,
Yes.
does the compass help us assign direction?
Yes, okay. So, yeah, I think it was. Okay, so in this example that we did now on momentum, they have given us the direction like this, north, east, south, and west. So remember, we can also, when you're choosing your direction, because they gave us this and they even described it to us as moving east, when I chose my direction, I said, choose east as positive. If they didn't give us this, then I would just say, I would have just said, choose the plus X direction as positive. Okay. So it doesn't matter whether you use these directions, north, east, south, or west, or you use plus X, plus Y, minus X, or minus Y. In the case here where it was given to us and it was also described, ball P of this mass moving east. So then we stick to this same notation. They told us it was east. When we give our answers, we give it in relation to east and west.
Okay, thank
you. Okay. Okay, so we're back here now. Oh yes, we were talking about what is, and it says define the term non-conservative force. So do you know when a force is non-conservative?
A non-conservative force is a force for which the work done in moving an object between 2 points depends on the pathway taken.
Very nice, that's correct. So a force is non-conservative if the work that it does on the object depends on the path taken, okay? It's non-conservative if the work it does on an object depends on the path. Okay. So the next question is 5.2. Calculate the change in kinetic energy of the car after it has traveled from point A to point B. Okay, so that's a nice one. What is the change in kinetic energy? Well, that's just easy. So delta K is equal to K final minus K initial. And K final is a half M V final squared minus K initial is a half M V initial squared. Okay, so we can write that as a half M VF squared minus VI squared. And we know all these values, sorry, so you can just substitute half, the mass is 200 kilograms, and we know that the final velocity was 2, and the initial, sorry, the speed, and the initial speed was 4. If you put that in, then you'll get minus 1,200 joules. Okay, that is the change in kinetic energy from point A to point B. Okay. Now the next question says, use energy principles to calculate the height h. So we want to know what h is. So here again, even using energy principles, there are many different methods you can use, still using energy principles to solve it. The one that I think is easiest is using the work done by the non-conservative force, is the change in kinetic energy plus the change in potential energy. So I'm going to do it like that. Okay. So I think that's 5.3. The equation I'm going to use is work done by the non-conservative force is equal to change in kinetic energy plus the change in potential energy. And what is the work done by the non-conservative force? Now remember, that is the work that is done by friction, which is 3.40 times 10 to the 3. And it is obviously negative. And then that's equal to, and now what is delta? Now delta K, we can rewrite it, or remember, we just calculated it above here in 5.2. So I'm just going to leave this as delta K. I'm not going to write a half M, this whole equation again. But we haven't calculated the change in potential energy, so we will write out the equation. So it's mgHf minus mghi. Okay, and remember, we are trying to find HF. So I can rewrite this. I'm just writing all the steps down. Maybe I'm writing too many steps, just so that you can follow. Okay, if you don't want me to write all these steps, then you can tell me and we can just leave out some steps. So minus 3.40 times 10 to the 3 is equal to delta K plus, we'll take out the mg and leave it as HF minus HI. Okay, so from this stage here, this is now the physics when we write it like that. And all the steps after this is just maths, and you can choose whichever way you like to solve it until we get to the last step. Okay, so minus 3.40 times 10 to the 3 is equal to minus 1,200. That's what I calculated above here. Plus, and then we know that M is 200, G is 9.8. We've got HF, and we've got minus 10. Okay. HF is equal to minus 3.40 times 10 to the 3 plus 1,200 plus 1,960, and we divide all of this by 1,960. Okay, and if you do that, if you do it correctly, then you will find the height. and it's 3/8, 8.88 meters. Okay, so like I said already, the question said using energy, using energy principles, calculate the height h. So there are different equations that you could use, energy equations. I liked this one, especially since we had just calculated the change in the kinetic energy. So that also saves you a bit of time. Okay. I think there's another part to this question. Okay. On reaching point B, the car's engine is switched on in order to move up the incline to point C, which is 22 meters above the ground. While moving from point B to point C, the car travels for 15 seconds at a constant speed of 2 meters per second. Okay, while an average frictional force of 50 newtons acts on it. And then for 5 marks, so lots of marks again, calculate the power delivered by the engine to move the car from point B to point C. Okay, so when you get these questions, you must read it bit by bit and make sure we understand the question. And when they give us all these bits of information, very often we do need it. Sometimes they give us extra information. In this case, we need this information. Okay, so we're trying to find what is the power delivered by the engine to move it from point B to point C. So before we can calculate the power, we should calculate the work done by the engine. Okay, so let's do that. In going from point B to point C, excuse me, let's calculate the work done. Okay, so for 5.4, I'm going to use the equation work done by the non-conservative forces is equal to the change in kinetic energy plus the change in potential energy. Okay, so work done by the non-conservative forces, so that is the work done by the engine plus the work done by friction must be equal to delta K plus delta U. Okay, now what is the change in the kinetic energy? So while we're here, let's just sort it out. What is the change in the kinetic energy if we are moving from point B to point C and it's traveling at a constant speed of 2 meters per second? The initial speed is 2 meters per second and the final speed is 2 meters per second. What is the change in the kinetic energy? Okay, it's just going to be 0. Okay, the change in the kinetic energy is 0 because the speed hasn't changed. Okay, plus, now delta U is going to be mg, and we can write it as hf minus hi. Okay, and we know these values. We're trying to find the work done by the engine, so that's what we're trying to find. What is the work done by the frictional force now? What is the work done by the frictional force? Okay, so to calculate the work done, it is the force times the displacement times cos of the angle between the force and the displacement, right? So we know what the force is. Let's just go back to the question so you're with me. The frictional force is 50 newtons. So I'm going to write on here, the work done by friction is equal to the force times the displacement times cos of theta. Okay, so what is F? F is just 50 newtons, it's given to us. What is the distance from B to C? What is the distance from B to C? It's not given on the graph, but it's given in this information here. The car travels for 15 seconds at a constant speed of 2 meters per second. Okay, so you know, you know that the speed is equal to the distance over time. So the distance is equal to V multiplied by T. Okay, and they told us that the speed is 2 meters per second and the time is 15. So for X, we can replace it by 2 times 15. And cos of, remember the friction acts in the opposite direction, so 180 degrees. Okay, so the car is going up here and the friction is acting in the opposite direction. Okay, so this is something that's a bit different, is how to get this X. So the work done by friction is 50 times 2 times 15 times cos of 180. Okay, so that's what I'm going to put in here now. So for the work done by friction, it's 50 times 2 times 15 cos of 180 degrees. Okay, so let's just make work done by the engine the subject, because that's what we're trying to find. It's going to be mgh. So let's just put in the values. M is 200, G is 9.8. The final height was 22 meters minus the initial height. We worked it out, 8.88, and minus the work done by friction, which is 50 times 15 times 2 cos of 180 degrees. If you do that, you'll get a very big number. We get 27,215.2 joules of work being done by the engine. Well, we knew it had to do a lot of work to push that car up. Okay, so that's only the part of the solution. The question was, what is the power? What is the question? Calculate the power delivered to move the car from point B to point C. Okay, so power is work done over the time that it takes. We just calculated the work done. And what was the time? They told us that it travels for 15 seconds. Okay, so the next part now, the power delivered by the engine is equal to the work done by the engine divided by the time that the work was done. And that is equal to 27,215.2 divided by 15 seconds. And then your answer is 1814.35. And it's joules per second, but we call power watts. Okay. So yeah, you have to work for the 5 marks. And also when you do these types of problems, now that we've done this, when you get a similar question, you know the method to use to be able to solve this type of question. Okay, so there were a few new things, I think, or maybe it was familiar to you. Do you want to ask me anything? No questions. Okay. Okay, question 6 on the Doppler effect. Okay, so let's read carefully. The siren of a train moving at a constant speed along a straight horizontal track emits sound with a constant frequency. A detector placed next to the track records the frequency of the sound waves. The results obtained are as shown in the graph below. Okay, so here's a graph of frequency versus time. And what can we see? We can see that initially it was a high frequency, and after some time at T1, it dropped to a lower frequency and remained constant. Okay, and then before we do this section, now we know about this Doppler effect, and we know that if the source is moving towards the observer or the observer is moving towards the source, we're going to hear a higher frequency. And if either of them is moving away, we're going to hear a lower frequency. Okay, so first question for 2 marks. State the Doppler effect in words. Oh. Okay, what is the Doppler effect?
Doppler effect is the change in frequency of the sound detected by a listener because the sound source and the listener have different velocities relative to the medium of sound propagation.
Ah, that is an excellent answer. It's a textbook answer. Very nice. Well done. Okay, so it is the apparent change in frequency. Or the apparent change in observed frequency. As a result of the relative motion between the source and an observer. Okay, so I'm writing out this here, even though these are theory questions, just to remind you that when you get these questions and they're giving you marks for it, there are certain important words or keywords that they're looking for. Okay, so when you get questions on theory, you must make sure that you get them right. Get them correct. Okay. So here, question 6.2 for 1 mark. Does the detector record the frequency of 3,148 Hertz when the train moves towards the detector or away from the detector? Okay, so what we do is we look at the graph and see, oh, 3148, that's the high frequency. Okay, it's higher than 2073. So if that is the higher frequency, it means that the train is moving towards the observer. Okay, so for 1 mark, it is towards. Okay, now look at this next question. Calculate the speed of the train. Take the speed of sound in air as 340 meters per second. And that is for 6 marks. Okay, so it's not difficult, but it's going to be a little bit of maths. Okay, so now we're trying to calculate the speed of the train. And what is the information that we have? We only have that the one frequency is 3.148. That's the high frequency, which means the train was moving towards the detector. And then we have 2073 when the train is moving away from the detector. Okay, so we're going to write those 2 equations out. So let's do that. So looking at your equations now, so you must use your equation sheet, okay? So the frequency that the listener hears is equal to V plus now V of the listener over V and V of the source times the frequency of the source. Okay, so now for the first one where we've got the high frequency, if we have the high frequency, it means that the source is coming towards the observer. So this sign is negative. Okay. Also, it says V of the listener. In this case, who is the listener? It is the detector that is here. A detector is placed next to the track. Okay, so is the detector going to move? No, it's not. So this VL is 0. Okay, because the detector is not moving. So we can now write out the equation, or we can put in the values here, right? So we have, I'm going to write the equation again as V over V minus Vs times that. Okay, and I'm just going to divide this page here because I want to write the other equation next to it so you can see. So when the train is moving away from the detector, then our equation is, it's going to be V again. Okay, I'm just going to put the VL here, and you know that that's 0. So when the train is moving away from the detector, then the sign here is going to be plus. Okay, so that's important when you are choosing this. If the source is moving away from the detector, the sign is positive. If the source is moving towards the detector, it's negative. Okay, so then I'm writing this out again. FL is equal to V over V plus Vs times Fs. And so putting in the values, we have 3148 is equal to, they said use 340 divided by 340 minus Vs. Okay, because we're trying to find Vs and we're multiplying all of this by Fs. On this side, we have 2073 is equal to 340 over 340 plus Vs times Fs. Okay, so from your graph, we were able to get these two equations, or to write these two equations. So we don't know what Fs is. It's the same Fs. So what we're going to do now is to just equate for the Fs. Okay, so you'll end up with 3148 here. We're going to multiply it by 340 minus Vs. And divide that by 340. And that is going to be equal to Fs. Okay, can you see that? We make Fs the subject here. You multiply by this entire part and divide by the 340. If we do the same thing on the other side here, 2073 multiplied by 340 plus Vs. Divided by 340. Okay, so then we have this equation is equal to Fs and that equation is equal to Fs, so we can just equate the two. Oh, yeah, okay. Okay, can you hear me? And can you see my screen?
We can't see the screen.
Okay, can you hear me now?
Yes, we can hear you.
The screen is not showing up.
Okay, so for this question, I don't know where I went off, but from the two values from the graph, we can write out the two equations, and then we can just equate them. Pardon?
You can't see the screen.
Okay. Okay, I'm gonna try again. Oh dear. Okay, I'm trying to share the screen. It keeps failing. Oh, okay. I don't know what to do because it's not allowing me to share the screen now.
It's 10 to. I think we have 10 minutes left, Ashla.
Yeah, and actually, I'm running out of battery myself since I'm on load shading. I think electricity is coming back in 10 minutes as well.
There's something maybe if you want to round
Okay.
this up today. And there's a
Okay,
question
yes.
about doing electricity. Do you have another session tomorrow, right?
Yes.
So the session tomorrow is at, it'll be the same link, and it'll be at 1700 hours to 1900 hours again, same time.
Okay, yes. If any questions, if anyone wants to ask me any question, I can just take a question, or we can just carry on tomorrow.
Ma'am, will you carry on with the paper tomorrow?
Yes, I will.
Okay, can I just ask what was the final answer?
It was 70 meters per second, 70.
Okay, it's correct.
Did you get that? Okay,
Yes.
well done. That's good. Okay, thank you so much for being so interactive and asking questions.
What time tomorrow?
I'm gonna post the link in the chat now. I'm post the website, which will show you the times. I just have a survey and a register for you to capture, okay? So I need you to go to the following link. I'm gonna post it in the chat. If all of you can just complete the following, just to record your attendance. Give some feedback. So tell us what we can do to improve, and tell us what we've done well. This will be very helpful to us, okay? Please, if all of you can just mark yourselves present with that. And I'll post the website now, the teaching and learning website. The teaching and learning website, it functions just as the pamphlet. So you can see all the session dates and pass this on to your friends on WhatsApp, and so that they can also see when the sessions take place, okay? We don't have a WhatsApp group yet. This is something we're working on. But if you have any questions for physics, you can put it on, you can send it to our email box. So these are the 3 emails, right? If you have questions about maths, you can send it to the maths email box. Physics and chemistry is there, and life sciences are there. Please take these important details down, copy them, write them down, do what you need to do. I'm going to leave the chat open for a while. So if you want to take some time, write the stuff down and follow the links and stuff, you can do that. And I'm just going to play a small video on the outro. Ashila, you can answer any questions that the students may have.
Oh, yes, sure. Any questions?
Doesn't look like we have questions. I think you can play your video, Ashwin.
While we're here, we can just take the information from the chat, and you can also post some questions while the video is playing on the chat so that we can tell you anything you want to know.
Part of the UKZN experience is the opportunity to be part of a community and to network with not only our world-renowned academics, but with future game changers and leaders. They do say that the extent of one's success can be attributed to those they rub shoulders with. Therefore, you must surround yourself with like-minded people. So, how do you become part of a community that is committed to your self-development? How do you become part of UKZN? First, you have to apply.
All applications for undergraduate studies at UKZN are processed through the Central Applications Office, CAO. This is for both your course and student residence application. The application process is as follows. Step 1. Consult the CAO handbook. This handbook provides a list of all qualifications available at UKZN. Step 2. Have a look through the various courses offered and choose a program that interests you and for which you meet the minimum requirements. As one of the top 5 universities in the country, UKZN promotes academic excellence. So meeting the minimum requirements does not guarantee you a place to study. Step 3. Find the program code linked to your chosen qualification. This is the code you need to enter in your application form. Okay, let me show you something. You see, a code has 3 parts. Example, for BCom in accounting, the code is KN-P-BCN or KN-W-BCN. Crazy code, right? Well, basically, the KN stands for UKZN, the middle part stands for the campus of your choice, P for Pietermaritzburg, W for Westfield. Then, BCN stands for the actual course. Make sure to get these codes right. Step 4. Use this program code when completing your CAO form, which is available from the CAO website. Your application will be sent to UKZN. You can always check the status of your application using your CAO number, ID number, or passport number on this website, www.caocheck.ukzn.ac.za. For more information, visit www.cao.ac.za.
It's that easy. Pay close attention to closing dates for qualifications. For example, MBCHB closes on the 30th of June, whilst other undergraduate programs close on the 30th of September. What are you waiting for? Apply now and shape your future today.
Okay, thank you all for attending. Again, if you have anything you want to ask, please put it on the chat. I'll wait it on for a while. And in 2 or 3 minutes, I'll end the session. Thank you. Okay, that's about it. If there's no more questions, if you have any more questions, you can send it to the email addresses, and you can keep an eye out to the Teaching and Learning website for further information about sessions and what's going on with more assistance. Okay, thank you. I'm going to end the session. Thank you so much, Ashlan and Zamzira. This was a very good session. I'm sure students benefited a lot from it. We'll see everyone tomorrow for session 2. Thank you. Bye-bye.